Zangpo. So today we're gonna talk about Gauss Law. If I do any mistakes, please tell me. Welcome to I Teach I Learn. I teach you learn. Anyway, what is Gauss Law? So Gauss Law, okay, start with me. Gauss Law. Gauss Law is, well, we use this law when we're finding the flux through a area, okay, through a very small area. So how Gauss took it was that, let's keep a point charge here. Point charge, Q plus minus. Okay, there's a point charge Q here. Now, this charge will make an electric field in like all direction. Okay, now he thought, let's put a surface here. Not a 2D surface, but a 3D surface. And 3D never a 3D surface, a spherical, a sphere. Okay, he wanted to put a charge inside of a sphere. Okay, so wait. Hello. Okay. So he put this charge inside of a sphere. He put a charge inside of a sphere. Now, this charge will produce electric field lines in all the directions. Zong. Okay, in every direction. Okay, now what we're trying to find is the flux through any of these areas. Okay, we're trying to find the flux maybe here, maybe here, maybe here, anywhere on this Gaussian surface. Okay, we only apply Gauss law in an enclosed surface, not an open one. Okay, and now sphere na Gauss law. Gauss law can work on any object. We use it on sphere because it's the easiest. Okay, so now what will happen is that the area here is very small. Okay, point charge. This point charge will produce electric field lines in all the directions, and each of these electric field lines will pass through a very small area known as dA. Very small. Okay, so what's the color is equals to EA cos theta. Flux through a given area is EA cos theta. We're trying to find a flux within an enclosed surface. Okay, Gauss law applies only on an enclosed surface. So electric field line, it will remain constant, but the area is very small. Okay, so how do we find the flux here? So how we find this? We integrate Gauss law, not only sphere. Okay, integration of closed flux is equals to integration of closed E dot dA. dA means small area. The only thing that that changed here is the area, and area is very small, cos theta. Tatame. Jodelama perpendicular minduga 90 degree. Cos 90 is 1. Madirutup. Not only here, gate joru perpendicular dio. Okay. Anai 90 degree dio, anai 90. Gate joru 90. So we just take integration of E dA. cos theta. Theta is always 90, so 1. Okay, so what we do here is constant chica 10. We are left with this E dot dA. Catch top answer. Answer, you can write it as Q by E naught. Q is the charge, E naught is the permittivity of the medium the charge is going through, passing through. So yeah, you can write this much, but let's prove. Hey, that's what you got. Okay. Proving. Okay. Flux E is equals to KQ by R square mole times 4 pi R square. QG extra by ina 한숨비 이모 E is equals to KQ by R square times 4 pi R square. Yeah. Oh yeah, my bad. Okay. KQ, what is Q? K is equals to 1 by 4 pi epsilon naught. Q by 4 pi epsilon naught times 4 pi R square. 4 pi cancel in an R square thing. Sorry, wait. Here an R square but the K mata pai, so here we'll have R square also cancel. So what are we left with? We are left with Q and E naught. See. Okay, so integration. This is Gauss law. The charge through a closed surface, enclosed surface, is this. It doesn't depend on the area. Area duga. No, area is very small. It depends on charge and medium, the flux produced. Gauss law last na June. Yeah. This again. Bera mas watching. Anichi memorize chapshada Gauss law half E se shape. Gauss law the chameba. Now we are going to apply Gauss law and find the electric field through a infinite sheet of charge. Okay, through a infinite sheet. No, infinite sheet ki point china charge karibanga. Yeah, tidome. Infinite sheet of charge chila. What will be the electric field at this point? We don't know. So how we'll know is we'll draw a shape. Okay. We'll draw a cylinder through this infinite sheet of charge. Cylinder ragachbe ina sinode debo sphere gachbe mabe. Sphere bewachin. Well, we'll have problem computing. Sphere the cylinder is best because vector area. Ani yeah. Flux na lablabo. Ana electric field jo delame. Electric field jo da ana surface chile ani pass through bedelo. Surface ki and straight, okay, like 90 degree perpendicular vector area. Nagi vector area tongkame. Okay, and in lab ki vector area ya thokame. masa khaleong. Okay, through surface le ani vector area anzumbet hindi ongse hagoiga. It's like porcupine zumbe. Porcupine gi back na point ani yeminate spikes lesha. I've spike gaira 90 degree anzumbe deu. Okay, so ani boat gi di vector area kachimo donkani zumbe. Okay. Ani gi kachimo vector area phata side pe wachin anzumbe. Ani side le anzumbe theno. This is the vector area. So in a cylinder, vector area hong bate gatte kutule hong karana le hong. We can cancel this. Why? 90 degree. Ana 90, ana 90, ana 90 degree. Cos 90 is 1. So cancel. Kate taru 90 hong. Okay. So we'll take this one and 90. Okay. The flux through this, all of this can be ignored except these 2 points. That's why we're taking a cylinder. Okay. Now, Kachwinda, well, find the flux through these two area. Kachwini, flux is equals to EA cos theta. Here cos is 0. Cos 0 be kachmo. What is cos 0? Okay, cos 0 is 1. Cos 90 is 0. That's any Gauss Law that's a mistake. The charge through this area will be parallel to the vector area. So cos is 0, cos is 0 more. So this can be ignored. 90 min 0. Sorry. Okay. Charge the vector area of that sphere. Charge the sphere vector area natong. Okay, all of this will be 0. Cos 0 is 1. Cos 90 is 0. Anakhale 90 degree perpendicular. Cos 0 is 0. EA anigi flux find out EA cos ngachekachme 90 mo. Cos 90 is 0. So any whole guy 0 jong. So flux through all of this yata. Anigi side na lebe 0. Another it is parallel. Cos theta is 1. Okay. Yeah. Any flux kachwani me. Well, anakay flux the EA chamchi mo. Cos 0 is 1, so EA anakachwani me. Anai flux is EA. So what's the total flux? Flux total is equals to 2EA plus 2EA. Flux is equals to 2EA, EA law. We're trying to find the electric field, not the flux. So what do? What we do is that Gauss law. This is an enclosed surface. So flux total is also equals to Q by E naught. Flux total is also 2EA. Flux total is only Q by E naught. And in closed surface, we can also apply this. The total flux is also this. This is equals to this. This is equals to this. So these two are equal. Q by E naught is equals to 2EA. Okay, write this down. Sigma is equals to Q by A. Sigma is charge density. How do we find charge density? Q by A. The charge divided by area will give you sigma. Okay. Q got to find benime. A sigma is equals to Q. A nata by 2G. Not done by important. Memorize sigma is equals to q by a, and sigma is charge density, how dense the charge is at the area. Okay, a nata by a sigma is equals to q is equals to a sigma. A sigma a cancel 2 nataba 2e is equals to sigma by naught. Take 2 here, you get e is equals to sigma by 2e naught. Bye.